In order to graph a sine or cosine function that has an h value or a phase shift with it, I'm going to begin the same way we've always done, by figuring out a few key aspects about my graph. For example, I know the amplitude of this sine wave is going to be 3. I know that the period is going to be 2 pi divided by the b value, which in this case is 2. So that would simplify down to just a period of pi. And then I know it's not reflected. I know that there's no vertical shift because there's no k value adding at the end of this. So the only other thing then is the new part of this, which is the phase shift. To find the phase shift, you're going to take the h value, and you may call it something different, but the number being added or subtracted in the parentheses, so in this case pi, and divide that by the b value, so which again is still 2. And then simplify if you can. So my phase shift is going to be pi over 2. And now notice it's the opposite of the sign that I have here. So that negative sign is actually going to move my graph to the right pi over 2 spaces. So that's the information I'm going to need to start graphing this. And if you need help with that basic stuff, then I'd go back and watch one of my regular sine videos. So to do this, the way I'm going to do this at least, is I'm going to start with sort of what I call a rough draft of what my graph would look like. So for example, I know my x-axis would normally begin at 0, and then it would normally end at the period, which we said was pi. And then finding our 5 key points, our 3 other key points, I need the halfway point, so that's pi over 2. I need half of the halfway point, so pi over 4, and I would need 3/4 of the way, which would be 3 pi over 4. And again, if you need help with finding those, watch one of my previous videos. What's unusual, and where the phase shift is now going to come into play, is that all 5 of those key points need to be adjusted. They need to specifically be adjusted using my phase shift. So what I'm going to do is take all 5 of those values and add to them, because I'm moving to the right. I'm going to add pi over 2 to each one of them to find out where these new points would be located on my new final draft of my graph. So let me go ahead and get that one started. Oops, I actually don't want to draw that yet. I'm going to draw in my x-axis, and again I'm just going to take each of the 5 values I had before and add pi over 2 to them. So using a calculator, if I don't want to worry about common denominators and all that stuff, well, that first point's easy. It's just 0 plus pi over 2 is pi over 2. Pi over 4 plus pi over 2 is 3 pi over 4. And again, if I was using my calculator, I would just add 1/4 plus 1/2 and then throw the pi symbol back on it. My next point on my rough draft was pi over 2. So adding my phase shift to that, pi over 2 plus pi over 2 is 1 pi. And I will continue on down the line just adding pi over 2 to each of my original values. So 5 pi over 4, and finally I ended up at pi over 3. And again, you can use a calculator and double check all that, but that's what we have. Now what I'm going to do is figure out where my y-axis would be located. Well, I can see that my points are getting bigger this way, of course. So my y-axis is actually somewhere back here, and so there's different ways to do it, but what I'm going to do is I'm just going to do that symbol to indicate there's like a break in the graph. And I mean, there's better ways to do it, there's more accurate ways to do it, but that's all I really care about. I don't care about being super accurate, so I'm going to do that. If you need to actually find where that is, then go ahead and continue this pattern and figure out where the y-axis would be. But I'm going to do that just to have a break in the graph. Now sometimes your y-axis may be over here, sometimes it may be somewhere in the middle, so we do want to take that into account. Anyway, I'm going to finish this the same way I'd always finish a sine function. So the amplitude is 3, so I'm going to go up to 3 and down to -3. And then there's no vertical shift in this, so I can go ahead and graph my function. Remember, sine begins from the midline. We're not starting from the y-axis, though, because that original point has been phase shifted, pi over 2 to the right. So that's where that first original point would be. The graph would then continue up in the sine graph, back to the midline. It would go low next and then finish back where you start. And to show just one period of this, I'm just going to connect those points. Try not to draw over your numbers if you can, and then I'll add arrows to show this graph continues. So that's one period. Now, of course, this graph does continue in both directions, and so eventually it would cross the y-axis at some point again. But I don't really care, to be honest, where it crosses. If you do care and need to be more accurate, then go ahead and do that. But for us, I'm going to say that is one period of our sine graph phase shifted pi over 2 to the right.